My name is Tom Coles. It's pronounced Coles, not Cools, because even according to my wife, I'm not such a cool guy. I'm from Belgium, and I work for a company called InfoSupport. We're a consultancy company, but we also do trainings. And I really like the mix that I get. I get to teach people a lot of stuff, but I get to work for big companies as well. And for some reason, one of our colleagues decided, you know what, we need something new promotional. We're going to make sauce. So we have awesome sauce now. I couldn't bring the bottles because they've unfortunately expired, but I do have the stickers. So if you want a sticker afterwards, just come to me, okay? But I'm not here to talk about my company. I'm not even here to really talk about myself. I'm here to talk about this little thing. This is a toolbox, but it's not just any toolbox, it's your toolbox. You each have an individual toolbox. And what the toolbox actually is all your experience, all your knowledge, all the things you've learned on projects, all the failures you've had. Because most of the times when you fail hard, those are the things that stick the most in your head. So whenever we do something, we add things to the toolbox. And it's really important to keep our toolbox up to date, because our industry is evolving very quickly, very rapidly. Every year there's a new framework. Now, I don't have a time machine. I don't have the DeLorean. I can't go to the future and show you what frameworks are going to come up. But I can take you back a couple of years and see what frameworks popped up in the recent years. And I really want you to try to imagine a world without these frameworks, because it gets really creepy in the end. So these were hypes back then, but now they're pretty standard. So let's go to the beginning of the year. Quarkus. Who has used Quarkus before? Not enough. It's growing up on the hype cycle. It's not been released that long. So imagine a world without this. It's very recent, so we can all kind of remember. GraalVM. That's more people have used that. Yeah, so raise your hand if you've used these ones. Spring Webflux. Ooh, silence. Okay. Kotlin. And that's only 2016. That's not even that long ago. So now it becomes creepy. A world without Kotlin. Ugh. Ooh, whoa, whoa, whoa. A world without Kubernetes? Then what were they teaching at conferences? Because it's basically Kubernetes now. If you go back a bit more, Spring Boot. Ooh. Ooh, imagine what did we do before Spring Boot? Does anyone remember? A few remember, but it seems like such a long time ago, because these are now standards. And then Docker. Imagine a world without Docker these days. I think Docker is usually a part of every conference talk that you get. So it's really creepy to think about these things. But these are things that come gradually. So our toolbox, we must keep it updated by learning new stuff, but there's a problem, and that's called the half-life. It's not about the game. I use the game because I'm a huge nerd. But a half-life is basically this. Half-life is the time required for a quantity to reduce to half its initial value. So normally it's used in nuclear physics, isotopes, blah, blah, blah. But there's also a half-life on knowledge. So what do you think is the half-life of knowledge in the IT sector? So how long does it take before half of your knowledge becomes irrelevant because it's no longer used? And I'll give you some advice. In 1920, so that's about 100 years ago, if you learned something then, it could take you 30 years that it's still valid. Half of your knowledge or more would still be valid. In 1960, it was about 15 years. So everything you learned then, half of it would still be relevant after 15 years. What do you think the half-life of knowledge is now in our sector? How long do you think it takes? Yeah, I see people looking at their clock. I think I just lost half of the day already. So how long does it take before we lose knowledge? That just becomes no longer relevant. Now, anyone want to guess? Yeah? 3, 5? Well, it's been estimated to be 2 to 5 years. So what this means is that we really don't have the time to not keep studying, to not keep accepting new things in our lives, and to really start working with them. So what I really notice is that a lot of people see a bunch of new stuff. You see it on blogs, you see it on conferences, but then they don't really know, what am I going to do with this? Because just seeing it, I bet if I ask you pop quiz questions about the first 3 talks of the day, most of you would fail because it's been a couple of hours. So imagine what will happen to the things that you learned today if you look next week. If next week you look back at this conference, what will you still remember? If you don't do anything after this conference anymore, most of it will be gone. So that's why I do this talk. I really want to show you that we need to keep learning, keep exploring, and I found a way that really helps me. And I have a few topics, but let's start with the first one. Because what should we be learning? It's a really important question because we used to learn from books. You just went to the library, you got a book, you open it. There was usually, for each topic, only one really good book on it. You read that and you thought, okay, so this is how I'm supposed to do C. But the world has evolved a bit. It's no longer just one book. It's an endless endless resources online where you can learn new technologies. So where do you learn a new tool? For me, it's these things. Twitter is a big one recently. I don't know, when Quarkus was released, my Twitter feed exploded by all the Red Hat people who were hyping it up, which is valid. It's where you learn new things. Does everyone know Technology Radar? No? Not a lot of people? Okay, this is not officially my presentation, but I think it's very useful. So, so let me just switch this here. Technology. So TOFWorks, which is a pretty famous company, actually releases a technology radar I'm forgetting, I think every quarter. And they list like the most important techniques and tools that they have. And they put it in different areas, like the adopt is, yeah, you should definitely be learning about this right now. And then you see chaos engineering is on trial. You have it for techniques, but also tools, languages and frameworks. I'm going to click that one. And there you see that TypeScript, Ktor, which is a framework for making small services with Kotlin. So you can get a lot of info on what frameworks are hip and upcoming. Let's close this one and go back to the slides. Oh, one back. You learn a lot from conferences, like what were the new things that you learned today? Well, if someone could name just one thing that you think, oh, I didn't know that yet. Micronaut. Anyone else? Come again? Kibana. Okay, cool. So you can learn a lot of new things, also from meetups. But there's one thing that you need to keep into account, and that's the zone of proximal development. It's a very fancy term for a very simple thing. Basically, the big center is the bullseye, but you don't aim for the bullseye because that's what you already know. So inside the bullseye is all the knowledge you already have. Now, the other circle, the blue circle, are the things that you are capable of learning. And the outer circle are things that you can't learn. It's a very simple model, but we often don't stop to think about this. Because it's not always very clear what you need to know. For example, if you want to learn Quarkus, what do you need to know? See? Yeah, JAX-RS. Because Quarkus, if you don't first dig deeper and you think, oh, today I'm going to learn Quarkus, but you don't know about Vertex and all the tools that it's using, then it's actually really hard to learn Quarkus as a framework and really get it. So it's really important that you know what do I know myself and what do I need to learn something. Because in the top area, the can't learn this, that's where you'll find frustration. Well, for me personally, I tried to learn machine learning because I was stupid and I thought, hey, I'm smart enough. I can learn machine learning in a day. But my math knowledge and matrices isn't that good. So really understanding machine learning, for me, is in the outer circle. I cannot learn that without first having a basis of other things. So when you try to pick up a new framework or a new tool or whatever, try to get very clear if it is in the circle of things that you're capable of learning and not just in the circle that's maybe a bit too far and you need to have more knowledge of other things first. Second thing we need to take into account is this, and that's something we forget a lot. Technical implementations fade faster than the concepts they are based on. What this basically means is, when I ask you, what do you want to try out now? After this conference, I give you a day, I'll pay your wages. What are you going to try out? This is a hypothetical statement, not a real promise. You said Micronaut, so yeah, Micronaut. Okay, cool. But if you think about it, and I don't know, I'm sorry, I forgot to ask, because this is a split conference. Who of you is more a Java developer? Can you raise your hands? Okay, and who's more JavaScript? A singleton, okay. Okay, more than welcome anyway. But what you see is that it takes a lot of effort to learn frameworks. But frameworks eventually, if you like it or not, I'm more in the JavaScript world, unfortunately, they recycle, they change. Now it's React.js, but then on the speakers dinner yesterday I heard, oh yeah, React, we're still using React. So there's always this fight. But the things that you can learn that are always important that will hardly ever change are other things. Focus on the concepts. What are concepts? Test-driven development. It doesn't matter what programming language you work, you can still do that. Behavior-driven development. Clean code. Whatever. There's a lot of core concepts that you can learn and study and that you maybe should focus on instead of picking up the next framework, because picking up the next framework is cool. Picking up a new framework, you get results pretty quickly. You get something really visual. But that knowledge actually decays really fast. You don't have, now Quarkus is booming, but who knows, whatever framework will pop up next year and then maybe Quarkus gets put in the bin again. But it's really important that we focus on the concepts, the core concepts that make our industry what it is. And then there's one more thing, and that's actually really the focus of my talk. Because you can have as much tools in your toolbox as you want. So, for example, you saw Micronaut today, so hey, let's use it in production. But if you then don't know how to apply it correctly, you get something like this. And that's a bit the problem I see when people ask trainings from our company as well, is that they saw something at a conference, they tried to use it immediately in production because they weren't given the time to actually try and experience it before using it in production. They didn't get time to make a small POC, or the small POC that they made that wasn't that good. Oh yeah, but it's good enough, we'll push it to production anyway. So that's something we need to worry about. So we need to practice, 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 and that's not always the fun part, but we can try to make it fun. And I call this learning through tinkering. So really applying what you learn during this conference and really go home or at your office and really start messing about with it. But what is tinkering? Because tinkering, in the first versions of my presentation, I didn't have a definition, so a lot of people were confused. What is it? What is it? What isn't it? So I call it experimenting with ideas and frameworks in an integrated environment to fully understand its capabilities. And the integrated environment is really important here, because the first time you launch a Spring Boot application and you make your Hello World REST endpoint, and you think, yeah, I'm the man. And then you get into more complex things like, oh, damn, I need to return XML, or I'm going to use something different. And then you get into real trouble. If you don't really understand what's behind it, you can run into real issues. So that's why you need to take it, whatever it is, if it's a framework, if it's Kibana, and use it in a really integrated environment. But then, when I talked about this, my colleague said, yeah, Tom, that's nice. I went to a conference. I want to learn. I'm going to take Micronaut now, sorry, because it's an easy one. I want to play with Micronaut, but I have no idea what to build. Does it happen to you that you're like, oh, I have this new framework, and I want to kind of try it, but okay, I guess I'll make a Hello World, because that's what I know? Well, actually, you could make much more fun stuff. So the next parts of my presentation are actually how I try to inspire myself to do a bit more than just the Hello World examples. And the first pillar that I try to do is really limiting myself. Limiting yourself sounds really weird because you're trying to explore, you're trying to discover new things, but actually by limiting yourself, you are forced to really understand a certain concept or a principle. And limiting yourself is really healthy because our brain is a bit annoying. Well, annoying, it's optimized. Our brain is optimized that when we see a new problem, we go back in history and we check, have we solved a problem that looks like this before? And then it will automatically apply the same solution to it. But sometimes this is not a good thing. Sometimes the previous solution worked fine in that situation, but this situation is subtly different. And then your brain tricks you into, oh yeah, I'll just use Spring Boot because that's what worked last time, but then maybe run into issues there. So we constantly need to be conscious, and by limiting ourselves, we kind of push our brain to give us new ways of thinking. So I'm a bit of a geek. I'm sorry for the non-geeky people. There's a lot of geeky examples. But I wanted to make this. So it's basically a Flappy Bird clone with simple bars. It doesn't have to be special. And then just build something. But I got kind of tired of this, and then I have a fascination with the game Portal. I don't know if anyone knows Portal. See a few nods, luckily, because else this would be a very weird thing. So I wanted to build a game. But to build a game, you need two things, basically. You need a game engine. So basically to render the frames each time and to update the logic. And then you need physics. Okay, I think maybe my plug's not correct. It doesn't matter. We'll see. We'll see. Okay. So I was lucky. So I was limiting myself. I want to make this game, but I only want to use Java. And I'm going to code everything myself. So you need two things. That's really annoying. You need two things. So one is a framework. And I found it online. It's actually made by, I don't remember the name, it's James Cho, I believe. And he has written out completely how to design a game framework from scratch in Java. And it's so elegant because it only uses interfaces for like the core of the logic. And then he has an implementation for each platform. He has an Android implementation. And I was like, hey, I want to use JavaFX. So I can just use the interface and then build something in JavaFX. So and that actually looks like this. Game loop. So you can see a bunch of different interfaces. And then I have a JavaFX implementation for each of those. So I found something online. I wanted to limit myself, and by limiting myself, I actually learned something about object-oriented design. Because if you look at the engine, it's only interfaces, so it doesn't matter what platform it runs on. Most of the core gaming logic can be just reused. Now, the second thing you need is physics. And as I said before, math is not my strong point, but I found some help online as well. Has anyone heard of Nature of Code? Raise your hand? No? Oh, yes. I fell in love with this thing. So basically, Daniel Schiffman, who has a ridiculously funny YouTube channel as well, made a book that basically explains from the very basics how to make a physics engine. And it's fully online, it's free in JavaScript, and he even has examples on how to model it. So you can see it looks really fluent and pretty real. So what does that look like? Well, basically, you have only one class you really need. It's in my physics department. There's three things you need, those three things here. So every object has a location, so I am currently standing right here. You have a velocity, that is how fast am I walking. So my velocity is now constant. I'm walking at a similar velocity. And then the third thing you have, and each object has an acceleration. And acceleration is really hard to explain, but I can go like, that's constantly changing my acceleration. And by impacting these three, you can actually make really realistic physics. Because all you do is you apply a force on it, and then you add the force to your acceleration, and each update loop, your velocity is changed by your acceleration, and your location is changed by your velocity. And by doing this, you actually create a very simple model. So I have this little game. It's not a game, it's just to showcase how the physics work in a very simple way. See? The cube falls. It's gravity. Can reset it. So very simple. And if you look at how it's implemented, you see here, I have some logic to reset the cube to the top, so that's when the space is pushed. And when it collides with the floor, I actually set the velocity to 0, so it no longer moves through the floor. And I apply of else I apply a force, and the force I apply is gravity. And gravity, if you look at how it's defined, it's just a vector. And basically, all we need to do to make a game more dynamic is add more forces. So a force we could add is, for example, the wind. And the wind is not a vertical force. Well, it could be, but gravity is more vertical. So wind is going to be a horizontal force. That's how we're going to model it. So I just changed this to something like this. So I have a new force. You can put this in a separate class and then make it pretty, but for demo purposes, I will do this. And if it is not on the floor, I'm going to apply the force to CC. That's the cube. It's called the companion cube in game. I'm going to apply the force being the wind. So now if I try this again, and hopefully he wants to cooperate. Oh. So if you saw, that was too much wind. Now imagine, imagine if you were doing this with x and y coordinates and you were manipulating the x and y coordinates manually. That would be tricky to fix now. But now, the way this is modeled, how do we fix the wind? We just change the variable. So you can make a little library of all the forces you want to make. I'm going to make it, maybe now it doesn't move at all anymore, but we'll see. So yeah, it moves like a little bit. So you have a lot of control over how you build these things. So actually, by limiting myself to only do Java, not only did I learn something about object-oriented design, but I also learned something about physics. So even something that's not even related to our standard practices, you get to learn new stuff. So, I hope it stops flashing when I switch to my slides. Oh. Yes. Yeah, okay, I can continue. So, limiting yourself is really the first one. And I'm out of luck, I see. So the next one is automate whatever. And I really mean whatever you can automate, just automate it. It's really simple. Well, it's not simple. It depends on your case. But my story is that I used to be a university teacher for 1 semester. And I don't know if they do it here in Portugal, but when students enter, you have to sign off that you've been there. Because if they don't attend, they don't get scores. So every day the lesson started with Roberto, Tom, and it takes like 5 minutes. It's boring, and I had to do it as well. So I thought, you know what? We have a camera. We just put it at the door. This is before GDPR, by the way, so no problems there. And there's something called the Microsoft Cognitive Services Face API. Has anyone used this before? No? It's actually an API, and you can send pictures to it, and then it does the face recognition for you. So I don't have to know anything about machine learning, so I can just implement this and have a cool little project. But there's a problem. I said the API accepts pictures, but I have a video stream. So I now have an option. I can just take one frame out of the video and send it to the cognitive service, but I have to pay this one for each call I do. And imagine if the camera is just pointing somewhere and for 10 minutes nobody passes. Then for 10 minutes long, I'm sending useless calls to this face API. So I decided I'm going to put something in between, and I used OpenCV. Has anyone used OpenCV before? A few people? Well, it's really great, and actually pretty simple if you look at the implementation of it. By the way, all of my stuff is just online on GitHub. I'll give you links so you can look at the code in more detail. So what this is basically a small application. I choose a video source, because you can have like a separate webcam and then you can use the webcam, but source 0 is my laptop camera. The great thing is that OpenCV comes pre-packaged with a trained model for detecting faces. So that's what I'm loading in there. The Cascade classifier is an XML, and that's just a machine learning model that you can load in. It's packaged with OpenCV, so I didn't have to do anything for it. Then a very passive-aggressive loop forever. And in the loop, I basically get a camera frame, which is what this does. I detect if there are faces, which are rectangles, it's very convenient, just rectangles. And then I draw the rectangles. And if I detect more than 0 faces, so if I detect 1, 2, or 3, then I send the entire frame to the cognitive services. So I made a small buffer. So what does this look like? There goes my camera. So you can see that I draw it. Oh, it's creepy. I don't know if you can see it, but there's like a green edge around my face. Okay. So in a very simple way, I've managed to solve my problem just by trying to automate my classroom so I don't have to take attendance every day. I had to learn about OpenCV, and I had to dig deeper into how are these things working. So trying to automate something is really a cool source. Even if it's something simple like an attendance list, it's so cool to learn new stuff. But I have to continue with a warning. Yeah, a grave warning. So these are not my students. I took a picture online. But at some point, one of these students came to me and he said, "Hey, Tom, I'm not getting detected, but I'm in your class." So I check the system. I say, "Oh, yeah, I can see, well, obviously you're here because you're talking to me, and I can see that the system didn't register you." So I thought, awesome, teacher moment. I can take this student. I can go with the student to my code, and we can figure out what was wrong. And we couldn't figure it out. And then I used this picture, and I thought, you know what? Instead of using a camera frame, I'm just going to use a picture and then use the algorithm on it. And I've never been so embarrassed in my life. Because this student had a darker skin color. And the standard algorithm was not supported. So this is a very embarrassing moment to have. So not only did I learn about OpenCV and even the knees being recorded, and I don't know how. But even though, now I lost my train of thought. So even though I learned about OpenCV, what I really learned here is don't take a machine algorithm online. Like train one yourself for your use case, or at least make sure you test something before you, oh yeah, it's a typical developer thing. Oh yeah, it works for me, so let's put it there and we'll see if something blows up. So don't do that. So that was automate whatever. The next one is replicating something. And I had big dreams. Does anyone know what this is? CERN. So what do they do at CERN? So they accelerate. We just saw it with the physics. We accelerate, and then what do they do then? They collide together. So you build this big circle. You make sure that 2 particles collide to each other, and they do that to discover more about our universe, because they hope that by colliding, things will break off. And that's something that we do in IT sometimes as well. But we call it reverse engineering. We try to take software apart and see what's actually going on underneath. Now, I was doing this little project in the summer of 2016, and I said I was a nerd, so what happened in the summer of 2016? Yeah? Brexit, no. That's not that long ago, I think. I'll release you and you can laugh at me. It's Pokemon Go. So the biggest mobile game that was amazing, because it's my youth. I used to be a big fan of the TV series, and now I could go out in the world and catch these little monsters. But of course, it became too popular and it started crashing. And then the IT guy in me thought, can I make it better? Because yeah, it's only a couple million users at the same time. How hard can it be? So I was looking up how does it actually work? Because that was my main interest. How does this game work? And I was lucky enough to find a Reddit group where they do reverse engineering of this game. So I don't have to do it myself, but I can piggyback and learn a lot. And one of the screenshots they showed me was quite interesting. Because this is the mobile app sending a request to the official Pokemon Go backend. And they intercepted the call so you could see what it is. Now, what my first surprise was, no chasing? Then it gets really quiet. Because everyone expects JSON. Like, we've been so used to making JSON APIs that it's hard to imagine that some company would, why would you change? Does anyone know what this is? Anyone heard of protocol buffers? So protocol buffers is a way to serialize your data. And it actually looks like this. Let's just see. Let me give you a quick example. Oh, shit. So this is what it looks like. This is a protocol buffer file. So it looks a bit like Java or any programming language. And you define your data structure here. And what it does is it creates, when you generate it, in Maven you have a plugin for it, it generates a class for you, which is here, which is ugly. Well, what it does is it actually allows you to serialize to a byte array and deserialize it again. Now, we use JSON, but JSON is a string. And a string, you have these base 64 encoding issues and all the other stuff. But you can just send bytes across the line like this. Now, why is this a good thing? Because actually, when you start comparing it, in Java to Java communication, it's actually way faster to do it like this. So not only do you get a schema, because it's a schema that you generate classes from, it's way faster. And the great thing is, protocol buffers can generate to Python, to JavaScript, to, I think, Ruby, and Java. So it's even multilingual and optimized. So strangely enough, I've been using this on almost all projects since, because I do some microservice architectures and stuff. And this is what we use now, because it's just way faster, and the schema really helps to make sure that the objects are the same on every part when you have a lot of communication between services. But I saw another nice thing. Somewhere deep in the code, they mentioned S2 cells. Anyone ever heard of S2? One guy. Cool. Apparently, there is something called S2 geometry. Now, let me take you through a small part of it. Because I learned about this through Pokemon Go, by the way. So this is like digging deeper and deeper. So how do they spawn all these little monsters across the world? Because there's a problem with location. And we don't think about this very often. But the location is usually a latitude, longitude. How do you index this in a database if you want to cover the world? How are you going to index it? You can't, because it's two properties. And if you change one of the properties in a way, it goes in all directions. So you can't really index a latitude, longitude. You can index it if you were able to map every point of the Earth with an increasing number. So how do you map the entire world in an increasing number so you can index it? Well, do you remember those lamps when you were a child, like the globe lamp? You had the globe and a light in the middle, and you turned it on, and then it was shining on your walls. Well, you put it in a box that just all the edges touch, and then you draw the reflection of it, and then you get this. Then you have the entire globe on 6 parts of a cube. And now you've divided it into 6 already. Pop quiz. How many bits do you need to get to number 6? 3 bits. So you need 3 bits to do this division. All right, we'll get back to that. Now, if you take one of those squares and you divide them into 4, you can put a line through it. So you can see it here. Oh, here. You divide it into 4, and it's 1, 2, 3, 4. And then the next line, that square you can divide into 4 again. And you can actually draw a line with an increasing number. And you can do it again. So these are all different levels. You can go as deep as you want to get to finer and finer grained areas. So this is what an S2 location looks like. It's basically binary. The first 3 bits are for the faces, so the different parts of the cube. And then it's always dividing through 4, so you need 2 bits to do the division by 4. And then you keep doing it, and then you have one terminator bit. And this way, you can have different levels in which you map the Earth. Increasing number. And increasing numbers are handy for IT purposes because those you can index. Now, what's also cool, if you want to know, this is a level 2 cell, if you want to know in what level 1 cell it is, you just take out this, and you move this one up, and then you know what level 3 cell you're at. So it's incremental as well if you look at the bits. And that's really handy if you want to do things on different levels. So for example, in the game, on a higher level, they calculate the weather. Because you don't need to know the weather for every centimeter on Earth. You need to know it for general areas. But for example, the exact location of a Pokemon, you need to know it on a meter level. So by doing this, you can index it and still have the different levels of how you want to divide your map. So, pop question. Level 0 cell, so that's one of those squares, has 85 million square kilometers. How many times do you need to divide it through 4 to get to 1 square centimeter? Please think while I go for a drink, because I'm thirsty. Yeah, divided by 4 each time, because it's always 4 cells. 13? That's optimistic. Anyone else? What? 13 or 30? 13. Oh, that's a bit too optimistic. But I doubt it if you said 30, because that's actually the answer. So it's 30 levels. So that's 30 times that you divide the square through 4, and then you're at a centimeter level. So that means 30 levels times 2 bits, because you need 2 bits to divide by 4. So, yeah. Then you have 3 bits for the initial phases, so the initial cubes. You have 1 termination bit. Look at the convenient 64 bits that you need to map every place on Earth. Every centimeter you can give an index that's 64 bits long. And then you can index it in your database. So it looks like this. This is a location. Or you put it in hexadecimal to make it a bit more readable. So by just trying to figure out how this, let's be honest, simple game works, I discovered a whole new way of handling map data and how you can structure the world and make sure that we save it in a different way in our database. So that's interesting to run into these little things. So trying to replicate something. In the end, I didn't replicate anything because I was too happy with the things I discovered that I started experimenting another way, which is fine. But one thing I want to say about replicating is that a lot of people think that they need to invent the wheel. Replicating is not a stupid thing. Replicate Netflix, go ahead. If you succeed, you will have learned a lot. But people think, oh yeah, it already exists. It's not cool enough to build it myself to get some experience. But I think that replicating something actually is very valuable if you want to learn new stuff. So if you think, I always want to do something new, that's not replicating, that's a business model. You sell it, you make money, and then you replicate something. Last one I have is a challenge. Because the world is made full of challenges. We have races. I don't know, what's the most popular sport here in Portugal? So we're gonna say football because I'm from Belgium, not American, so it's football. Okay, so we're constantly challenging each other, and we do that mainly to prove that we're better than other countries if you go on a national level, but also to really challenge ourselves to get better. And my company did something really funny. We call it the War of the Tanks. I'm going to just show you what the tank actually is. So we had 11 teams. Each of the 11 teams got this tank, 250 euros and some time to make a war between the tanks. Because you see this little blue dot here? That's an infrared receiver, and the tank actually shoots infrared light, so they could really fight each other. So I don't know if this is gonna go. Oh, no. Back. Oh. It's not much, but. So you could drive the tank and then. So the challenge was actually to make it fully autonomous, and then it can shoot, and you had to make sure you had power banks because the Raspberry Pi is in there, it needs to get power somehow. So for who of you would immediately want to do this? So you get 250 euros per team, you get the tank, and you get about 3 days to work on it from your company. Who would say no to that? Everyone would do it? Yeah. We thought the same. We thought the same. And it was normally 4 challenges. So the first challenge was just drive the tank without the official controls. Then the second challenge was each time more complex and more autonomous. This is what it looked like after the second challenge. Nobody was participating anymore. Well, almost nobody. So that leads us to another chapter of today. Why do we stop? Why do we stop experimenting before it's actually done? One of the reasons could be I don't like doing it. That's a valid reason. But it has to impact your career then. Because if you make a chatbot, for example, and you really don't like it, then you know when someone on LinkedIn says, hey, I work for a chatbot company, do you want to come work for us? Then what you've learned from that project is that you don't like doing that, and that's very valuable as well. It's an important career choice to know the things that you like and then don't like. So even if you don't like it, in the end, you've learned a lot by trying to do it anyway. Too much new stuff, because that's something dangerous. Especially now, you come back from a conference and you want to use Micronaut or Quarkus with Kubernetes, and you instantly want the Kibana cluster with it for the logs, and you want to deploy it with Jenkins. And the talk of Andy before was about testing. I want to fully test it with everything. And that's, I think, where often we go wrong. We don't have focus on wanting to learn something. We try to learn too much at once. And that actually slows you down quite a lot. Because if you're trying to learn a new framework, learn a new thing like a chatbot, which is totally different from building and some other things, and a new database, and this and that, you think, oh, I'm going to learn a lot, but actually you're just slowing yourself down. Because it's too much to learn at once. Because learning is actually scientifically proven that it's connecting new information to information that you already have. So if you're trying to learn too many new things, your brain is just going to short wire and just go, oh, damn, this is way too much information. I can't maintain this pace. And the last one, and this is, I think, where my company didn't mean it, by the way, to this next part, but it's misplaced competition. Because what happened with our tank battle, and our managers didn't anticipate this up front, was that it's a competition. So they divided the teams. You had senior people and junior people, and then you make them fight, the teams, within the same company. So what happens? Anyone venture a guess? You split the team. So a lot of the people quit, and that's mostly the junior developers, because the seniors were too competitive. And they said, yeah, I could teach you how to do this, but it's faster if I do it myself. So then the junior people were usually like, yeah, okay, then I guess I'll just sit here and write documentation. Oh yeah, we don't have to do documentation. Okay, then I just quit. And there's a lot of other people that just had to learn too many new things. So I was totally not into electronics. I luckily had a teammate who was. But we didn't really have the time to share the knowledge to make sure that I knew something about electronics for when that damn thing fails, that I can still do something. And one other thing is that we had 3 days, and there was a little quirk in the competition. Mainly, if you won the battle, you didn't necessarily win, because there was also a jury prize for the most fancy tank. But how do you make the most fancy tank if you only get 3 days?
And only 250 euros.
Yeah, okay, the 250 euros is not really a big deal. But they wanted to inspire passion, but what they actually were inadvertently, so it was not their intention, but they were actually rewarding unpaid overtime. Because the teams who won were putting way more time into the tank than that we were given. So it's a really creepy boundary we need to take care of when we talk about challenging. So I talked about time. when should we be doing this thing? Because I can say to you now, yeah, you should apply and you should go experiment and you should go do, but when should we do it? When we run out of options. That is the sign of desperation. No, so I'm a trainer as well, and I also do like usually when a training is requested, it comes in my mailbox eventually. And what I'm seeing is more and more trainings where they ask, can you please give the training from 1 in the afternoon till 8 in the evening? Like before lunch, they just have to work and then they have to follow a training till 8. So I'm seeing really a growing emphasis on learning in your own time. And I think we all feel it a little bit. It's if we don't use our own personal time to learn more and more, then we will fall behind and eventually be irrelevant. And I really am not too happy with that. Because do I think your employer should give you time to play with these things? Absolutely. Absolutely. Because I see a lot of people here who have been to a conference and you've learned a lot of new things. How long do you think you will keep that knowledge if you are not going to use it in the next couple of days? Hardly any. What?
Half-life of a week.
Half-life of a week, yeah, basically for the new things. This is Bloom's taxonomy, and it's basically a model on how you teach children and the things that are needed. And everything on the bottom is really a base to do the top things. So if you look at this, remembering something, so remembering about Micronaut, Kibana, Kubernetes, then at least you can go look it up. So that's really the basic, the remembering. Understanding is the next level, because if you can't remember how to do Docker run and you need to look it up all the time, then you don't really understand how Docker works. So that's the next level. And then you have the green level, and that's the really most important one. That's applying. Just taking all the knowledge you have and start doing things with it. Because what do companies want from us? Those top 3 things. They want you to create something new with the knowledge that you have. They want you to evaluate and make judgments. What database are you going to use? Are you going to use Kafka? Or are you going to use... To be able to make those decisions and judgments, you need to have all the bottom part as well. And analyzing. Yeah, if you don't know how to analyze your problem, then good luck trying to find a solution for it. And it's already a win-win story. So if your company says, yeah, fine, but we sent you to a conference and that's about it for you now, so now you have to work for the rest of the year. It's already win-win. Because if you look at it, when you get these opportunities, and with the tank project, I've never been more motivated to learn new stuff. It's really amazing how much you can get motivated just by playing around, but in a more structured way. You get more self-confidence on project as well. Imagine that, I'm going to take you again. Your next customer asks you, yeah, we're going to build something in Micronaut. How confident are you today? Not really. How confident would you be if you had like a week where you just tried it out for yourself? A lot more. So that's beneficial both for you and for your company. And going to your company, well, if you get all these nice opportunities, why would you go away? So there's less turnover. You can keep the same people for a longer time. You can grow the company from within, because I see a lot of companies that hire juniors and then they get a bit older and then they leave. But if you can keep those people, then you can really grow people that you had from junior all the way to architect and maybe even, manager. And better productivity, because, the more you know, the faster you can develop. Most important advice, share what you've learned. I do not speak at conferences very often. This is my first this year. It takes a bit of effort, but it's worth it, because I learned a lot just by preparing these slides. I learned a lot by making a demo to show to you today, but also to my colleagues. So by pushing yourself to share what you know, even if you don't know it yet, that's the trick. You can just say, I'm going to talk about this, and then you're forced to learn about it. But if you have to share it, if you have to teach it again, then you look differently at things that you learn. Because you know, oh, I have to teach this to other people, so you're more focused. So let's finish up. Who's responsible to maintain your knowledge and skills? Yeah, you are. It's that simple. Because this is your toolbox. I started with it and I will end with it. Talk is almost over, okay. It's good because I'm crashing a little bit from heat. So it's like my brain is throwing Stack Overflow exceptions. So this is your toolbox. It contains all the tools, and by now you know that we need to constantly update, upgrade, and maintain your toolbox. I've shown you a couple of ways, so a couple of things you need to take into account, and the most important thing, I want you to go home, take some time, or make some time, or ask for some time, and go tinker with something. Really go do something, because you're here. Don't let the knowledge that you gained today go to waste. And I'll finish with this. If hours and hours of watching Bob Ross paint doesn't make you a better painter, then hours and hours of JNation won't make you a better developer. So, I thank you.